Closure in Python. There is a close relationship amongst nested function, scopes of variables and closures in Python. So, before defining what a closure is, let's begin with nested functions. Nested function is nothing but defining a function inside another function. Here is an example. Here, the inner underscore function is being nested inside the outer underscore function. Now we may call the inner underscore function from inside the outer underscore function as shown here. Now call the outer underscore function with an argument, hello. Now let's run the codes in a terminal and check the result. We can see here that the inner underscore function is able to access the argument passed to the outer underscore function. When we call the inner underscore function from inside the outer underscore function, the argument passed to the variable message is still in memory. So, the function call inner underscore function inside the outer underscore function accesses the variable message normally. Now let's check what happens when, instead of calling, we return the inner underscore function. Now let's call the outer underscore function and assign the returned function to a variable f. As the returned function is assigned to f, now we may call the function this way. As we can see, the returned function is working fine. But how? After execution of the outer underscore function, the variable message should have gone and become inaccessible to inner underscore function that was returned to f. But, the variable message is still accessible to inner underscore function even if the outer underscore function is not in memory. And here comes the concept of closure. Actually, a closure is a function object that remembers values in enclosing scopes even if they are not present in memory. Here, the variable message and the inner function forms a closure. That is, even if the outer function does not exist, the variable message is accessible to the inner function. Closure comes into picture when 1. There exists a nested function in our codes. 2. The inner function refers to a value in the outer function, and 3. The outer function returns the inner function. Please note that the scope of the variable message is non-local to the inner underscore function. We can check the closure property using this statement. Let's run the code first and see the output. For making the variable message accessible to both the inner function and outer function, Python creates an intermediary object known as a cell. The output shows that the cell and the object are two different memory locations. We may illustrate these objects in the following way. This is the cell. This is the object, hi, a string object. The cell can be referred to by both the outer underscore function and inner underscore function. The string object, hi, is accessed indirectly via the cell by both the functions. This is how even if the outer underscore function is not in memory or the outer underscore function is deleted, the variable message will be accessible to the inner underscore function returned by the outer underscore function. Let's introduce another variable n and check the closure property again. As we can see, only one cell is created for storing the string object hi, no cell is created for the integer object n. This is because n is not being used by the inner function. Let's use n here, and recheck the result. As we can see, now two cells are created for two variables message and n. It demonstrates that only the variables that are used by the inner function becomes part of the closure. The variables that are the part of a closure are also known as free variables. We can list the free variables using the property _code__co_freevars. Let's run the code and check the result. And these are the free variables, and these are the part of the closure. That's all about closure. Hope that you have understood the concept. Thanks for watching. Please like, subscribe and share your valuable feedback. Bye.